Good morning. We're going to do the second part of the mutations lecture today. So it should be fairly fast. There's only 2 slides. So the first, just a reminder though, mutations are going to be anything that changes the nucleotide sequence in your DNA. Friday we talked about the point mutations where there's a change in a nucleotide, just one sequence. So this is, well, that's Luke, so sorry about that. So there's frame shift mutations. They can be a specific type of point mutation, but basically what happens, oh, and I have another typo I see. This should be or, not or, as in like, not iron ore, sorry. So a frame shift mutation, it kind of does what the name implies. It's going to be a shift in the reading frame. So this is where you either get an extra nucleotide inserted or a nucleotide gets deleted, and then it just messes up the entire strand. These types of mutations tend to have a very huge impact on the protein that's formed. So it can happen during replication or transcription, either one, when the DNA strand is getting read. So you can have a base deletion, which is a specific type of a frame shift mutation, or a base insertion. So, and those are pretty easy. Either you're deleting a base or you're inserting one. The example that I have is a base deletion. So you have your original sentence. It's got, pretend like each word is a codon, because each word is actually 3 letters like a codon would be. So let's say that the original DNA strand read "the cat ate the rat." And then what happens is the C gets deleted. So then everything shifts, and then you have the "atta, tet, her, at." So that obviously changes the entire meaning of the sentence. Same effect would happen with the DNA strand. So you're either going to get, you will get a brand new protein, because you're going to end up with totally different codons. The flip could be said for if you inserted an extra word, you still would not have the original sentence. So let's say instead of taking out the C here, we ended up putting another word in here. That would obviously shift everything. And so you can kind of see the detriment that one base deletion or insertion has on the protein. Here's some other specific types of point and frame shift mutations. So a silent mutation is going to occur. That's going to be a point mutation. And what will happen there is kind of like back on that that slide on Friday with the point mutations. There is technically a mutation, so there is technically a different nucleotide or a different nitrogen base, but you still end up getting the same amino acid. So this right here, this would be a silent mutation right here, because the A is changed out for a G, but they still both code for tyrosine. So even though it's technical mutation, there was no real effect. You still get the same amino acid, so it's not a severe mutation. So those are called a silent mutation. Okay, the next one is a missense mutation. This is a point mutation also, and it's going to involve the substitution of a different amino acid. So you might get, you're going to get a different amino acid formed. If it happens to I guess technically you could say that a missense mutation could also kind of be a nonsense mutation, which we'll talk about here in just a second, but you'll get a half-form shape because maybe you end up with a half-form protein. If you get a different amino acid, you will more than likely get a different shape because remember that sequence of bases is that primary structure of the protein, and then you'll get your secondary shape, either the helix or the beta plated sheet, depending on what sequence you have with the amino acid. So if you have a different amino acid, you could get a different shape. So nothing gets changed in the reading frame, so it's kind of like this one down here, sort of. Instead of an ATC, though, because this is technically going to be a nonsense mutation more than a missense mutation, but you could argue that this could also technically be a missense mutation because you are getting a different codon, technically. But I would actually call this a nonsense mutation, actually. But you kind of get the point. What a nonsense mutation is, you get the change in the base sequence and you end up getting a stop codon in the middle of your protein, or maybe at the beginning. Basically, you get a stop codon too early. And so you end up getting a protein that may be too short to function. I mean, obviously, if it's halfway formed, it's going to be too short. It's not going to function. So, on your worksheet that you're going to get, you're basically going to have you're going to have a DNA strand, and you'll change it into you'll go through transcription, and then you'll go through translation, and then what you'll do is I'll tell you to change the basal, or I'll change the base rather, and then you'll have to translate it. And then from that, you're going to have to tell me, is it a base deletion? Is it a base insertion? Is it a silent mutation? Is it a missense mutation, or is it a nonsense mutation? You won't really tell me if it's a point or a frameshift mutation right off the bat, because remember, the base insertion and deletion are going to be frameshift mutations, and then the silent, missense, and nonsense mutation are going to be point mutations. So when it asks for the specific mutation, it'll be one of these five. So the base insertion or deletion, or silent, missense, and nonsense. From there, I can't remember. I'd have to go and look at the worksheet. I might ask you if it's a missense mutation, is it a frameshift or a point? So these three right here, I don't know why I have frameshift mutation, because they're not frameshift mutations. These three are point mutations, and the insertion deletion are going to be frameshift mutations. So that'll kind of give you an idea about the worksheet. If you do have questions, please ask. And just don't forget, there's a quiz on Friday. No class on Thursday because of the musical, and I actually won't be here Friday, so you'll still have your instructions and everything, but I won't be here Friday. So next up is the worksheet, and again, like I said, if you have questions, just let me know.